this thing on. Okay. That was Jawbreaker. I don't know if any of you have ever heard of Jawbreaker, but it's like literally the best band in the entire universe. And they're playing a reunion show after like 21 years this year, so homage. Anyway, I'm Devon. Hello to all of you. I am here from a little company that you might have heard of called Apple. You guys know that place? This has nothing to do with that company, but we are hiring UI and UX in case anyone's interested. My team eats ice cream and it's really rad. Anyway, this is a side project that I built, and it's really awesome, and it has to do with React. But it all starts, I brought a little clicker so that I could not be hidden by the podium. If anyone wants to borrow that, that's fine. Okay. So this is a talk that begins with robots, as most awesome stories do. I'm obsessed with robots. I think they're really awesome. I think that, I, for one, welcome our robot overlords, and I will give them a key to my house. I think there's an interesting intersection that happens between robotics and technology and humanity that'll help us sort of evolve into the future. And that's where it all begins, is me wanting to be a cyborg. It's like part of my 5-year plan. So that's the thing. So then we're going to talk about NFC. Okay, this is a cool picture of me and my boyfriend at the time. I say boyfriend at the time because we just got married. Yeah, we just got married a couple days ago. Thank you. This conference means like everything to me. It's my favorite conference in the whole universe, so there was absolutely no way I was going to like get married and miss this conference. So so I'm here. A couple years ago, he was like, let's get NFC implants. And I was like, what? And then I was like, absolutely. So NFC is this cool technology. It's a subset. So I'm not an expert on this by any means. Please look up anything that I say because I might be lying. And so there's this technology. It's called RFID. It's radio frequency identification. It is a way to give like so you have a device that is able to like emit signals and capture signals, and then you have something else that's like a key that has a primary key on it, and then you can do things based upon that primary key. RFID is like a huge, it can read like up to 100 meters. Near field communication, which is NFC, near field. I didn't know that at first. I thought it was like some proper noun, but near field is like, it means like close proximity, right? Within a couple inches. So I have an NFC implant in my hand, and it's pretty cool. Some real life applications of NFC technology that you probably know day to day as when you use your card to tag in and out of your hotel room, that's NFC technology. Or if you have a card that you use to get on and off mass transit, and then it tells you like how much money you might have left on your card and like gates entry, that's NFC technology. If you have a little badge that you use to badge into doors at work, that's usually NFC technology. So that's what it is. It's just a little chip the size of like a piece of basmati rice that you can feel in my hand, and it's pretty dope. What NFC is not is like Big Brother tracking me all the time. There's no like signal. It's passive. So I'm not putting out a signal into the universe so that somebody can tell where my location is at any given time. It responds to a handshake. It's like a crypto type thing. So a device can ask it a question. I can choose whether or not to respond to it, and respond only with this unique identifier. Another real-life application actually is sometimes people talk about microchipping their pets. You guys familiar with that? Yeah. So like they insert the exact same chip into the scruff of your pet's neck. And if any of you have ever lost your pet, you'll know that they can't, like Big Brother, they can't track your pet down and find them. They have to find your pet and then scan it, and then that's a primary key in some database that they host that has your personal information so that they can track you down. Anyway, that's NFC. I'm an expert. I mean, not an expert. I mean, whatever. Okay. So next is this really cool thing. So I wanted to talk to all of those things that I was talking about, all those real life applications for my hand. I wanted to like scan into my hotel room and be a cyborg, but nobody wants me to do that. It's like a security issue or something. And like even my work, they were like, well, we'll let you do that, but we have to have write-only access to your hand, which sucks because it's my hand. I want to write to it, right? Like I don't want everyone else to be the only ones writing to it. So I bought a house, and I subscribed to the Internet of Things methodology. This is an actual photograph of my house. You can tell because of, actually, okay, I think I'm supposed to say like, this is free from the internet, courtesy of the internet. I downloaded it from the internet. The internet gave me this picture. Anyway, so I want to live in an episode of Black Mirror. I want to walk into my house. I want my house to be like, Devon, we noticed you gained 3 pounds. You are not allowed to have pizza for dinner. And then like, your temperature is a little high. Here's a glass of orange juice or something. Or like, your shoes are worn through. We ordered you some new ones. I want my house to like recognize me, know what I'm doing, and like give me awesome shit. Oh, I have a potty mouth. Anyway, that's what I want to live in, and that's what I built here. You can tell there's like 2 robot cogs giving a handshake, and then there's like some instant messenger on a computer, and then there's like Wi-Fi access from a tablet, and then you can see there's a dollar bill in a cloud. That's where I'm buying the shoes. And yeah, so this is how an Internet of Things household actually works scientifically. This is a fact. Okay, so I want to intersect those 2 things. I was talking to my friend Ryan Florence. He's your friend too. You guys know him. He's over there. And I was like, I got this NFC implant, and I want to operate at my house. And he goes, my mind is blown. You are Peanuts emoji, which I am, the actual manifestation of a peanut emoji. And then he followed it up with, could use React hardware. And I was like, absolutely. And a CFP was born. And then I'm here talking to you about NFC with React. So I built this whole thing with React. It's going to be awesome. To start this project, as I start all of my projects, this is the shut up and take my money emoji. I shopped on the internet and bought all of the things, absolutely anything that I could get my hands on, because I hypothetically want to wave my hand and have my house buy me shoes. Yada, 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 profit. So I don't know how to do any of that stuff in the middle, but I have a feeling it has to do with open source technology and a bunch of hardware. So I start buying things online. The thing about hardware, though, is that it is hard. Like, there's an extreme barrier to entry to doing anything that has to do with hardware. There is like a time barrier to entry. Everything's long lead. And then once you buy something, you're not sure it actually works, given the other things that you've purchased. On top of that, you could spill like water on it, and you can't just like npm install new microprocessor. You can't do that. You have to order a new one, wait for it to show up, and then like do things to it to physically manipulate it. So hardware is really hard, and the first several months of this project were me just like flailing under the idea that I was going to succeed somehow in hardware. So here's a photograph of all of the things that I purchased and I did not use for this project. It's a lot of stuff. There's cool things, like there's definitely a future here. This guy right here, this is a Sonar Speaker. So I can like tell when somebody's coming close. I have no idea how to use that. There's some LCD screens, there's like some number stuff and a bunch of LEDs. Anyway, this is all of the things that I spent money on and I didn't use, but maybe one day I potentially can. Here's an interesting factoid you guys probably know, but I didn't. Arduino and Raspberry Pi are not the same thing. Everything on the internet is like, oh, this is the RFID reader for your Arduino Raspberry Pi. Here is a screen for your Arduino Raspberry Pi. So it's like, obviously, one is a subset of the other, one is a brand name of the other. That is not true. So the first thing I bought was the Arduino, which is the blue guy on the left, and I really tried really hard to make that work. I ended up abandoning it for the Raspberry Pi only a couple months ago. I took like a day trip out to Fry's, which is like a big deal if you're from San Francisco. Like you gotta rent a zip car. It's a big deal. So I bought the Raspberry Pi. Raspberry Pi barrier to entry is incredible. There is a huge community. Anyone here that's contributing to that open source community is great. Drivers are readily available. People are communicating. Plus, it has onboard Bluetooth and Wi-Fi support, which is really great. It was a lot easier for me to figure out how to like SSH into it before I could figure out how to get drivers for a keyboard and mouse. All of these things are really difficult when you are working in a new technology, new hardware technology, especially that you're unfamiliar with. Just the ability to like I/O into it is really hard. Raspberry Pi kind of mitigates that a little bit. So yeah, Raspberry Pi was the way to go. Arduino was a waste of money. This is also some wasted money that I spent. So hypothetically, in the far future, what I want is a box that sits on the outside of my house. I scan my hand and shit happens. So I obviously need a power source for that, unless I want to hire an electrician, which I don't, because that's expensive, and I'm obviously doing this from scratch. So I bought this battery pack. That never worked at all. That never supplied any power at all. So then I bought this lithium battery pack, which was really cool for a little while. It was able to satisfy, like, the original drivers that I bought were in Python, and it ran those. And like my lightweight little node server, it ran that. Here's something that sucks. As soon as I introduced Webpack and React, that was drawing too much processing power with the hardware for this to work. Even with the full charge, I couldn't supply enough power with a lithium battery pack. So thanks, React, for that. Yeah, so these both went in the garbage. Oh, here's fun. This is fun. Okay, so this is the first RFID device that I bought. This is super cool. It's like for people who work at NASA and want to like read fancy things from far away and spy on people. Like, this is what hackers buy so that they can like scan your credit cards and like steal your credit card information from you. I can't figure that out. I couldn't figure that out. Anyway, it's an RFID reader, and it actually doesn't read in the same frequency as the chip that I have in my hand anyway, so massive failure. What I ended up getting, though, was this PM532, which is like the gold standard for Nfc Technology, just so everyone knows. Are you taking notes? Yeah, so this was great. There's a huge community for it. They write drivers, they respond to issues. That was really fantastic. So PM532 is what I went with. On the bottom there, just so that you understand the platform a little bit better, is a little dongle that you would use to like tag into your condominium building or something. That's the same chip that I have in my hand, just with a more secure shell, I guess. It's less breakable than my hand, at least. So yeah, here's something crappy though. I don't understand. Okay, so the PM532 comes with like a bunch of little wires and is like, solder these to make work. Why? Why can't everything just come soldered? There's no like special configuration. Just charge me an extra $2 and solder it for me. Instead, I had to buy, so soldering's really interesting. It is a extremely hot metal wand that will burn the F out of you. And then you take a stick of metal and you turn that metal into molten lava, and then you make pins stick inside a board. And you can only use like 0.5 millimeter in diameter of the molten lava at a time. Otherwise, the currents will, like two little pins will connect together and create a current, and then you have to buy a new one. So yeah, soldering sucks, and I'm not good at it. I shake, I'm like a little chihuahua, and I can't do it. So somebody else had to do most of the soldering for me, as you can see here, unmanicured fingers. Okay, here it is working though, right? So here's a little light. That means, whoa! That means I'm working, Devon. This is great. So this is the Raspberry Pi on the left-hand side connected with a ribbon to a breadboard, and using like GPIO on the breadboard to like an SPI as a serial parallel interface on the PM532, we were able to power it up and make it start communicating. So this is really cool. This was the first time that we actually felt any success with this project. So big deal. This is a big deal for me. We celebrated with Lucky Charms milkshakes from Burger King. Those are, yeah. Anyway, those are great. So I bought this plastic case and Tetrised everything inside this plastic case. This is by Honeywell. It's something that you put over your thermostat so your kids can't change the temperature while you're away from home. Yeah, it's so great. And then everything fit inside of it, and here's the final product. It looks really beautiful. Here's the thing. It's NFC blocking, so so I couldn't actually scan my hand, and I had to take it apart. So that's pretty good. Okay. Here's the better part, because here's the thing that we're all actually good at. We're here for a reason. Software is less hard. Pardon the pun. No, don't pardon the pun. Puns are fun. Okay, so software is easy, right? Everything that I wanted to do at this point, I could search for on the internet, download, mess it up, download it again, reinstall, reconfigure it, and I was able to have a lot faster wins. My trajectory kind of went like this versus like this for the first 4 months. So here's some, here's some libraries that I used. This is by Adafruit. This is the Python version of the SPI that actually talks to the PN532. So what this means is that you do whatever you do in your language, but it has to somehow translate to something that the breakout board will understand. Parched. So yeah, we used this, and it was pretty dope. But this is a React conference, so I don't want Python code. Someone, I don't know who, open sourced this. It's PN532-SPI-JS. You can get on NPM. So it's that entire library written in JavaScript. So now I have a JavaScript thing that I can use with my JavaScript project. So this was very important, otherwise I couldn't read from my hand. Oh, okay, so have you guys heard of Johnny 5? Yeah, Johnny 5 is by Boku. Yeah, and it is like a robotics and Internet of Things thing. So if you want to tell your house to buy you shoes, you have to use Johnny 5. There's no other option. But really what it does is like make things happen on whatever board instance that you have. So like make some lights flash or make a sonar or whatever you want to do. So Johnny 5 is a really important part of this project. And Boku also have a JavaScript version of the API. So that's what I used. Johnny-5, that's pretty cool. Yeah, I used that, it was great. And then in order to do I/O, to talk directly to the board, to like translate to the Johnny 5 layer, I used Raspi.io, which is pretty much the industry standard. Raspi-IO, and that's specific for the Raspberry Pi. You obviously wouldn't want to use that if you were like developing on a different platform. So, oh no. Well, I expected this. I'm pretending to be sad. So the literal barrier to entry into my house, literal, is something called an August. Have you guys heard of August? Okay, so I have August locks on my door. August is a lock system that you can use Bluetooth on your mobile phone to unlock and lock your phone. Then if you're an admin for the account, you can also distribute temporary keys for other people to lock and unlock the door. August is super secure, and they don't have an API, which is fine because it's the barrier into my house. Like, I want that to be gated a little bit good. This super cool guy, what he did, it was called August TTL. There's still a cache of it on NPM, so you can still download it, but you can't view the source code or anything like that. Well, you can after you download it. Anyway, you know how NPM works. So what he did was he sat in front of his door with his iPhone, and he sniffed packets that were sent back and forth between the two devices and reverse engineered the August lock. And that's pretty cool. Luckily, some people's process, I guess, is that you never trust that a repo might not be taken down, so we forked it before it was taken down and have it. I'm not going to distribute this, but if you have any questions or you want it, just holler at your girl and she will share it. So you can see here, he's talking about how to get the keys from your plist. We found an old iPhone that was unlocked and grabbed the plist in order to get these configuration keys. And we had to do some subtle manipulations, but that's not that big of a deal. But then you're able to call this lightweight node server and just call lock and unlock, and it's pretty rad. Yes, okay. Okay, oh, well this is kind of crappy. So I built this lightweight little React app using Create React App because I wanted people to be able to manage their profiles, people being me and my SO. So I would distribute a username and a password. You would go in, you would enter in your UID, which would become immutable later on, and then you could start building up your profile of things that you wanted in the house to happen special for you. For instance, your Nest temp or your Sonar station, or like what you want for dinner or your shoe size or any of those sorts of things. I'm serving this from the same Raspberry Pi because I'm not good at databases, and I'm just like directly writing to a JSON store that I'm reading from, which you'll see in just a minute. So this isn't super secure, but at least I have a way for people to be able to build their profiles and add additional UIDs. And then enters React hardware. So React hardware is React-hardware. That's from I Am Dustin. This is super cool. This is the example that's running off of Raspberry Pi, off of Johnny 5 instance, which is what I decided I wanted to do because that's what everyone does, and I'm a follower, I guess. I don't know. And so yeah, this allows you to get an instance of a Johnny 5 board and talk to it and pass that into a React hardware render method. And that's what I used, and it was really easy. I'm not sure it's the long-term solution to my project, but it's definitely something that got me off the ground, and it's something that you can use too, because put a React on all the things, you know what I mean? Okay, so let's look at some code, I think. Okay, bigger. That's big enough? No? Well, okay, so this is the entire React file. You can see it's less than 100 lines. The important part down here is the React hardware.render method, in which I'm passing in an instance, I'm passing in my component and an instance of Johnny 5. Oh, and be forewarned, this code's not great, but I broke it. And so I wanted to be honest and show you the last code that actually worked rather than like good code that might not work. So judge me if you want, I don't care. Okay, so in my constructor here, I have two state variables, a red light and a green light. Here's my plan. Just to make sure, I want to give the user some sort of feedback that what they're doing is working. So you scan your hand. If I successfully scanned your hand, I want to blink. Blink, 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 something's happening. And then, as soon as I found a match and I've tried to unlock the door, I go green. As soon as unlocking the door is complete, I go ungreen, and that way you know you can walk in the house. If any of those steps fail, we obviously stop like blinking a light or don't ever show the green light. So that's the red light and the green light here. And the GPIO is just the pins. If you remember those wires that were connected in the board? This just is like an indices of where those pins actually are to tell the Raspberry Pi where to send it. In my componented mount, this is just a key so that you understand the language of the SPI in the PM532. So I create an instance of that, and as long as I don't have a match, oh, and here's something else. So I'm using a global variable here because I'm using React 16, and you guys know that set state doesn't always work in componented mount. Yeah, so I'm using a global variable, and that's that. So as long as I don't have a match, I'm debouncing reading the RFID constantly, 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 constantly. As soon as I find a match, so it returns a byte array, like a 255 byte array, but I need to turn that into something that I understand, so I convert it to a hexadecimal string, and then compare that against this local configuration that I was talking about that I'm storing locally. It's just a configuration JSON file, and it has an array in it of UUIDs. And then as soon as I have a match, I start blinking the red light. This works, everything's fine. And then I call initialize August. August is kind of a cool little thing. What it does is it scans the Bluetooth airways and tries to find an instance of an August device. When it finds an instance of an August device, that's peripheral. It says, okay, here's my specialized configuration keys. Can I cooperate with you and unlock you? That's when you do connect. And then I just pass it in unlock, and then it's magic, and it works. So this is promise callback hell, and it kind of sucks, but it is what it is. So I stop the red light and turn the green light on, and then in the finally, I'll turn the green light off. If there's an error, I will start again, so that the user knows that they can do things. Your render method in React hardware always returns null. So that's it. That's the whole code. I think I escape. 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 Okay, so there's an inappropriate log statement in this, and I apologize, but it's the last video I got. So here we go. Here is it working. I'm debouncing, I'm debouncing, I'm debouncing. Here's the open box. Here's my lock. You can see it's turned all the way counterclockwise. It's locked. Uh-oh, there's sound. Okay, so here's me scanning my hand, scanning it. You can see why I needed the light, right? You can't tell. So now it's blinking. That means I successfully scanned your hand. Turned green. That means I can successfully unlock. And it unlocked. Fuck yes! Victory, 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 victory. This was so great. This was like such an emotional day for me. Yeah. The cool thing about this, though, was that then I started hammering it because I was refactoring my code trying to make things work. And the August device does not allow the same configuration key to be passed in it more than every whatever seconds, and it locked me out. So, and August has a backup plan for this. They do this so that in case somebody's trying to break into your system and they're not able to get in or whatever, I have to call a 1-800 number and explain to them about how I was reverse engineering their product, and ask them politely to let that configuration key in again, or I can just distribute another key and then sniff those packets and then whatever, blah, 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 blah. Anyway, this is the last time I got it working. It was like just a few days ago, like the day before the wedding, and I'm proud of it. So this is the obvious future. I need to get a case that works. I need to get a case that's secure. My cat also, like, her name's Wi-Fi. My cat called Wi-Fi slammed the case onto the ground and everything kind of smashed into a million pieces. Nothing broke because I'm really good at soldering. I mean, somebody is good at soldering, but yeah, it needs to be secure. So maybe some sort of 3D printing case would be rad. I need a constant power source, especially if I'm going to continue using React and React hardware. I need to actually mount it outside and make security work again, and then I need to figure out some sort of security layer because if I'm going to be hosting primary keys, UUIDs outside of my house, I think that somebody could steal that and like come in my house. That's not cool. And then the less obvious future. Okay, so we talked about React. You guys know that I should figure out a better code there. But here's something that's hypothetically rad. I could give one of those little dongles to my dog walker, and when she shows up to watch Ziggy Stardust the dog, I could unlock the door, and then I have this little pet cube that has a public API that I use it to FaceTime with my dog. So I can turn that on so I can spy on them, and then there's this pet net, which is another robotic thing that I have that feeds my pets at certain increments, so I could trigger a feed event, and they could hang out and eat dinner and stuff. Okay, so I have an Instapot. Do you guys know Instapot? Yes, Instapot. So I have the one that's Wi-Fi and Bluetooth enabled. So I could scan my hand and turn on dinner, right? That's awesome, and have like chili 30 minutes after I walk in the door without even having to do anything. That is incredibly awesome. And then finally, my Black Mirror dream of the future where the whole house turns into Devon mode and I get shoes all the time and somebody pours me orange juice. Anyway, that's it. That's the whole project. I'm pumped about it. I'm stoked. If you have any questions, I won't answer them here. Okay, bye.